Okay, dear students, in previous classes we already discussed about how to find the dimension and basis and how to find the null space and definition and all. In today's class, we will see what are all the fundamental subspaces of the vector space, subspaces of the vector space or column vector. Okay, this is the first subspace is column space of A. Four fundamental subspaces are column space of that matrix. Here A is a matrix. Column space, null space, and row space, and left null space. We already know about column space and null space of A. What is column space? Linear combination of that column vectors, and null space is which is the solution of X is equal to 0. But what is row space of A? Row space of A, which is nothing but column space of A transpose matrix. Here, column space of matrix A, row space of A, which is nothing but column space of the transpose of that matrix, and left null space, which is also same as the null space of A transpose matrix. Here, null space of A is null space of A, then left null space of A is n of A power t, transpose of that matrix. Okay, we will see that dimension. What is the dimension for that these four fundamental subspaces? Dimension is rank of A. Here, for column space, dimension we calculate dimension using rank, which is denoted by small r. Rank is denoted by small r. And for null space, dimension is n minus r. N minus r. Here n is number of vectors in the vector space Rm. Here n is number of vectors in the vector space R power m. Okay? N is the number of vectors. Here R is a rank, which is nothing but rank. Row space of A, which is denoted by C of A power t, the dimension is R, which is same as rank of, which is same as dimension of column space, which is rank. And the left null space of A is null space of A power transpose, A transpose. Left null space of A transpose, which gives left null space of A. The dimension is m minus r. The dimension is m minus r. Here m is the number of elements. Here m is the number of elements in each vector. Number of elements in each vector. Vector in the vector space Rn. R is the real vector space. M is dimension. Therefore, here these are all the four dimensions for four fundamental subspaces. Therefore, we will see one example on this, how to find the dimension for these four fundamental subspaces. First, consider the given example. Given matrix is 0. The problem is determine the four subspaces in 3D space, in three-dimensional space, with the matrix A is 0, 1, 0, 0, 0, 1, and mention their dimension. Okay. First, we have to find what is the column space of A, and null space of A, and row space of A, and left null space of A. Then we see what is the dimension for these four fundamental subspaces. First, we have to find column space of A. Here, we already know that we want for dimension rank. Therefore, we find rank first. Here, what is rank? Number of non-zero elements in the matrix. Here, number of non-zero elements is first row and second row. Third row is 0 element, 0 row. Therefore, the rank is here. Rank of A is 2, which is denoted by also small r. Rank is r. First, we have to find column space. Column space of A. Column space of A. What is column space of A? C of A is linear combination of the column vectors. Linear combination of the vectors, which is x1 0 0 0 plus x2 1 0 0 and x3 0 1 0, which is also denoted by the span of these vectors. Span of these two vectors. The vectors are 1 0 0 and 0 1 0. 0 1 0. This is the column space of A. Next, see row space of A. Row space of A. We are using this row space of A. Row space is, before that we will find what is the dimension for the column space of A. What is dimension? Here rank is 2. Therefore, the dimension which is denoted by DIM, dimension of the column space A, the column space of A, which is equal to rank. Rank is which is equal to 2. Dimension is rank, which is equal to 2. Second, third, we will find what is the row space of A. Row space of A. Row space of A, which is denoted by row space of A, C of A power T. This is also linear combination of these vectors, but the matrix is A transpose. Here A transpose matrix is 0 0 0. We write this column as row, first row 0 0 0 and 1 0 0 1 0 0 0 1 0 0 1 0. This is the A transpose matrix. The linear combination of these vectors, linear combination of these vectors gives the span of these two vectors, because the third column contains 0 0 0 elements. Therefore, we write span of what is column space of A transpose. Column space of A transpose, which is nothing but row space of A. Row span of the vectors 0 1 0 and 0 0 1. This is the row space and column space. For this, dimension for the column row space of A. Row space of A is dimension of row space of A is equal to what is same, which is same as column space. Column space of A, which is the dimension of column space of A, which is equal to row space of A. Therefore, row space of A, which is equal to 2. Rank, which is equal to rank. Rank is equal to 2. Okay. Next, we will see the null space and left null space. The dimension of null space and left null space. We already found that what is the dimension for column space and row space. Now we will find the null space of A. Here null space of A is what? Which is the solution of Ax equal to 0. Consider this equation. Consider A is 0 1 0 0 0 1 0 0 0. A is 0 1 0 0 0 1 0 0 0, and x is nothing but containing x1, x2, x3, which is equals to 0. 0 means 0 vector, 0 column vector. This one. Multiply these two matrices, we get 0x1, 0x1, x2 plus x3 plus 0x3. Therefore, we write x2 is equal to 0 from this equation. Right? 0x1 plus 1x2 plus 0x3, which is equals to 0 means, which implies x2 is equal to 0. Okay. It's 0, 0. Therefore, x2 is equal to 0. First row, first column, and second row, first column. 0 x1 plus 0 x2 plus 1 x3, which implies gives x3 is equal to 0. x3 is equal to 0. Then we have x2, x3. Then let x1 is some scalar, some quantity k. Then we get null space is, the solution is, null space of A. The solution of A is equal to 0, which is equals to x1, x2, x3, which is nothing but, what is x1? x1 is k and x2 is 0, x3 is 0. Therefore, it is also written as k common and 1, 0, 0. Here k is some constant, or you can directly write it as 1, 0, 0. This is null space of A. The dimension for the null space of A is n minus r. Here n is the number of vectors in the vector space R power Rm. Therefore, here the dimension is one. How 1? N is 3. Here n is 3 cross 3. Here 3 dimension space. Therefore, n minus r. How? Dimension of null space of A is n minus r. N, where n is 3 minus r is 2. Rank is 2. The rank of the matrix A. Here we have taken rank of the A transpose. Rank of A transpose, which is same as rank of A. Here A transpose, which is rank of A transpose is number of non-zero rows, same as A. Therefore, the rank of A transpose and the rank of A is 2. Here 3 minus 2 is equals to 1. Therefore, dimension of n of A is 1. Next, we will find what is the dimension for left null space. Left null space is, for left null space we want A transpose is 0, 1, 0, 0, 0, 1, 0, 0. This is the A transpose. The rank of this matrix, rank of A transpose is number of non-zero rows is 2. The null space, left null space of fourth one, left null space of A is denoted by n of A transpose. N of A transpose means here, which is the null space. Null space is the solution for A transpose X, which is equals to 0. Consider this equation. Null space is the solution of A transpose into X. Therefore, A transpose is 0, 0, 0, 1 0 0 0 1 0. This is A transpose. X is same as x1, x2, x3, and 0 is 0 vector 0 0 0, or we can write directly as 0 1. Multiply these two matrices, we get first row 0, therefore second row, we continue with the second row 1 0, 1 x1 plus 0 x2 plus 0 x3, which is equal to 0. From this we get x1 is equal to 0. From this x1 is equal to 0 we get, because 0 0 0 0 0 into x3 is 0 0, then we get x1 is equal to 0. In third row we multiply by third row 0 x1 plus x2 plus 0 x3, which is equal to 0. From this equation we get x2 is equal to 0. Therefore, let x3 is, x1 is 0, x2 is 0, let x3 is some scalar quantity k, which is scalar. Therefore, we get the null space of A transpose. Null space of A transpose, which is nothing but left null space of A. Left null space of A is the vectors, column vector x1, x2, x3, which is equals to x1 is 0, x2 is 0, x3 is A. 0 0 A here, or we write directly, we write it as 0 0 1. A is semi constant, which is the left null space of A. Okay. Then the dimension for the left null space of A is m minus r. Here m is number of elements in the vector. 1 2 3. Number of elements in the vector. 0 0 1 means 1 2 3. Therefore, here m is 3. Therefore, m minus r is, m is 3 minus r is rank of A transpose matrix is 2. Therefore, 3 minus 2 is 1. This is dimension of left null space.